Throughout my career, people have argued that like there's this one thing that's all you need for AI. And there's this essay by Rich Sutton, The Bitter Lesson, that tries to make the case that this one thing is scale and compute. I will say during my PhD, everyone's like, your models are too complicated, Joey. You need simpler models and lots of data. This is what Google was pushing, the unreasonable effectiveness of data. Turns out we wanted bigger models. The history is full of, there's this one thing that you need to do, and that is all of AI. And I think having gone through many stages of a different one thing, I can say with some confidence now that it's many things working together that give us the breakthroughs that we have today. When we think of what maybe are the interesting questions today, I as advising many graduate students, is something I have to constantly think about. There are a few that I'm pretty excited about right now. One is, how much can we do entirely on top of the models that we have? What is sort of the limits of what can be achieved without ever touching a gradient, without ever changing a weight? And I think it's important as you start to build products on top of some of these foundation models. As a researcher, I like to hedge. So the other extreme view that I really want to understand is if I could change the weights, how far could I push that? And so we have access to open weight models. We're doing a lot of work in reinforcement learning and post-training, but I want to go deeper. Like, could I change the weights in a conversation? Could I change the weights? Could I actually incorporate knowledge that we would store in memory into the parameters themselves by taking gradient steps on individual piece of information as we discuss them? So if my model was able to learn continuously at the parametric level, what would that unlock? And so these are things that we're thinking about now and trying to build systems around to better understand.